CCA matters because Anthropic sees it as a technical certification. It's for solution architects building production, Claude applications. The exam isn't about memorizing features, it's about proving you can choose architectures under constraints. You must connect systems safely and securely. You need to turn Claude from a chat interface into enterprise infrastructure. Most candidates study Claude like a product manual. That misses the point entirely. Production systems fail at boundaries. Unclear tool contracts cause issues. Overloaded context leads to errors. Brittle prompts break under stress. Unsafe automation creates risks. Weak retrieval hurts performance. Missing recovery paths cause failures. Exam pressure tests architectural judgment, not feature recall. Study the domains as one operating system. Agentic architecture decides the loop. MCP and tools expose action. Claude Code operationalizes development. Prompting shapes behavior. RAG controls knowledge. Reliability keeps the system trusted. When conditions change, trust remains. Agentic architecture is the highest leverage priority. It determines whether Claude should answer, plan, or delegate. Claude can call tools, spawn subagents, or stop. Claude Code subagents run in separate contexts. They have custom prompts, tool access, and permissions. Delegation is a design decision. Claude API docs. Tool design is not just API decoration. It's about interface architecture. A strong tool defines a clear task. It accepts predictable inputs. It delivers structured outputs. It handles errors in a recoverable way. It enforces permission boundaries. MCP matters because it standardizes connections. It standardizes how AI apps interact with files. It standardizes access to databases. It standardizes tool integration. It standardizes workflow orchestration. Claude Code deserves deep study. It turns reasoning into real repository actions. It reads codebases with precision. It edits files directly and accurately. It runs commands across environments. It integrates with development tools. It works in terminal, IDE, desktop, and browser. The real test is whether you can control this power safely. Check the Claude API docs for details. Prompting is not just clever wording. It serves as the control plane for roles. It defines tasks and constraints. It includes examples and evaluation criteria. It manages escalation logic. Anthropic's console tools focus on generating prompts. They support templating and testing. They enable continuous improvement. Study prompting as an iterative engineering loop. RAG is where Claude stops guessing and starts grounding. Search result content blocks support source attribution. They're especially useful for retrieval augmented generation. Applications need accurate citations to work well. Study chunking, metadata, and freshness together. Include re-ranking, refusal, and citation behavior too. Think of them as one evidence pipeline. Refer to the Claude API docs for details. Reliability is not a final checklist. It's a design layer across every domain. Permissions come before tools. Validation happens after tools. Fallbacks are ready after failure. Observability follows deployment. Human review precedes irreversible actions. Hooks matter because they fire across Claude Code events. They trigger during tool calls too. Claude API docs. Study in this order: agent loops, tool boundaries, MCP integration. Claude Code workflows come next, followed by prompt patterns, then RAG pipelines, and finally reliability drills. Do not isolate topics when learning. Every strong answer shows a chain from user, intent to context, action, verification, recovery, and governance. Complete the chain. Turn every study session into a real-world scenario. Act as a customer support agent using Claude. Simulate a code migration task with Claude. Use Claude as an internal knowledge assistant. Build a data extraction workflow with Claude. Set up a multi-agent review system with Claude. Define what Claude should see in each scenario. Decide what actions Claude is allowed to take. Specify what Claude must not do in each case. Make failure visible and measurable in each setup. The winning mindset isn't about knowing Claude, it's about designing a Claude system that survives production. When you explain domain trade-offs as architecture decisions, the exam stops feeling like trivia. It starts looking like the work itself,